Hi, I'm Don Vickers from the IBM Channel team. Today, I'd like to provide an introduction to a core technology that IBM has now included within both its public and private cloud offerings. IBM has invested in making your cloud computing options more seamless between our private and public cloud deployment options. Enterprises often are pursuing all three of the following cloud use cases: cloudifying their existing legacy applications which are running on their own premise, extending those on-premise solutions with new cloud-based capabilities and services from IBM's cloud, and finally, building cloud-native applications from scratch on IBM's public cloud platform. It's important to protect all three of these various investments and architect for future flexibility so that you can move your workload to the optimal deployment platform at any point at future time. Containers have become a very popular vehicle to modernize cloud applications. They are a core component of IBM's cloud platforms. Containers allow porting to a wide variety of platforms and cloud providers, and they are easy to manage. They reduce the consumption of resources versus the older virtual machines. They share more resources and reduce the size of what you have to carry along when you package your application to port it to other environments. Containers align very well with the recent trend of microservices architecture, in which applications are very often coded such that there's one service or microservice per container. That allows you to scale up and determine availability options on each container independently, which gives you a great deal more flexibility as you deploy it to a cloud environment. Applications and overall solutions can often consist of very many numbers of containers. Tooling to effectively manage and deploy all of them is crucial. A good container orchestration tool helps you structure your containers' runtime placement, manages their ongoing health while they're running, distributes the workload, and scales for performance. Service discovery allows the user request to be effectively distributed to the containers wherever they're located in this very dynamic runtime environment. IBM has now integrated the industry's leading open source container orchestrator, Kubernetes, into our latest version of IBM Cloud Private. Along with the existing container services on our public cloud service, this now provides a consistent way to manage and deploy your containers across your cloud environments, whether you're on your own premise or in one of IBM's cloud delivery centers. Let's take a peek at some of the key capabilities of Kubernetes. Through a unified API, Kubernetes runs and manages your containers, deploying your application components to runtimes which are then monitored and maintained. Updates to the applications can be deployed in various methods without disruption to a running application, and Kubernetes supports a wide range of environments, giving you a great deal of flexibility in selecting your runtime environments. As an open source project managed by the Linux Foundation, this technology has been widely adopted by several cloud providers. IBM is an active member of the project and contributes to its ongoing development. Beyond IBM, Kubernetes is supported by several major technology companies and has been widely accepted by cloud providers. This has led to support of a wide range of deployment options and protects its users from being locked into one environment. Kubernetes is organized around clusters when deployed to the runtime. The master node controls where containers within pods are deployed, all within a set of worker nodes. The structure within the worker nodes allows for scaling, availability, and network connections of your workloads. A few of the key roles played within the Kubernetes nodes are the proxy, which runs on each node to provide network connection, the scheduler, which places your workload while managing to performance and capacity goals, and the API server, which acts as a front end to the clusters and services the REST operations which are coming in to the environment. One or more containers is run within a pod, which is the smallest deployment unit. Each pod has its own IP address, shared storage for its containers, and it's all co-located. Each node is either a virtual machine or runs on a physical machine. Pods can be used to match resources to the utilization levels of your workload and the goals you set up for performance based on resource utilization. Kubernetes will automatically scale up or down the number of pods deployed based on the parameters you've defined for the deployment. Using the elements of a Kubernetes deployment, you can build out various levels of availability. Deploying the smallest unit, a single pod, you can fail over by using a persistent data store or a persistent volume. By deploying multiple pods within a single replica set, the work can continue on the surviving pod if one of the individual pods fails. By creating redundancy at the replica set level, you can further leverage the load balancer of your cloud provider, and you can even distribute your cluster across different physical data centers to further reduce common points of failure. This was a real quick introduction, but I hope it gives you a flavor of the power of efficiency and control that you get in managing this new world of containers in the cloud environment by using Kubernetes, which is now a core element within IBM's cloud provision architecture. Here on this final chart, I've listed several other resources. I highly recommend the self-study tutorial on the Kubernetes site. The base tutorial is free, although you can pay for a small fee for the privilege of being tested and officially certified in that topic. And then there's follow-on tutorials available on that site. I hope this helps you on your journey to cloud computing.